Assalamu alaikum viewers. Today we'll be discussing one of the important topics of radiological physics, transformers. As you all remember, we all were taught about transformers in our intermediate physics. So our aim for this lecture will be to recall and refresh that knowledge. Let's begin. Transformer. Before we learn about transformers, I would like to share why this topic is important in radiology. In high voltage circuit of X-ray generator, step-up transformers are used to convert the main voltages, which ranges about 120 to 240 volts, to the high voltages, which range from 20,000 to 150,000 volts, required for X-ray production. It also transfers electrical energy from one circuit to another by mutual electromagnetic induction. Transformers are essential part of an X-ray machine, in order that current supplied through the mains may be converted into suitable form for the operation of an X-ray tube. Transformer is a static device that changes the intensity of alternating voltage and current, either increasing or reducing it. First, you have to understand why is the transformer called a static device. Because transformer has no moving parts as like in the induction motor, which has a rotating magnetic field, rotor, and also torque generated in that motor is a rotating in nature, so that the machine has a rotating part to complete its process. But in transformer, complete process of transferring the power can be done without any rotating part. मतलब कि ट्रांसफार्मर के मुकम्मल अमल होता है और पावर की मुंतकली किसी भी घूमने वाले हिस्से के बगैर की जा सकती है. That's why इसे स्टैटिक डिवाइस कहा जाता है. Now we will understand the transformer law. Yes, here we can see the formula for the transformer law of voltage. V is for voltage, N is for number of turns. Voltage of a secondary circuit divided by the voltage of primary circuit is equal to the number of turns on the secondary coil divided by the number of turns on the primary coil. In short, it states that the change in current is inversely proportional to the ratio of the number of turns in the primary coil to the number of turns in the secondary coil. Also, if voltage is doubled, current is halved. The quantity of number of turns on secondary coil upon the number of turns on primary coil is known as turns ratio of the transformer. Transformer works on principle of Faraday's law of electromagnetic induction in the form of mutual induction. Mutual induction यानी कि बाहिमी शमूलियत. The principle of mutual induction states that when two coils are inductively coupled and if current in one coil is changed uniformly, then an EMF gets induced in the other coil. आसान अल्फाज में इसे ऐसे कह सकते हैं कि जब दो कॉइल्स की आमदगी के साथ जोड़ा जाता है और एक कॉइल में यूनिफॉर्मली करंट तब्दील होता है तो दूसरे कॉइल में भी ईएमएफ पैदा हो जाता है. Now we will discuss the construction of transformer. Usually it consists of two basic parts. One is magnetic core and other is windings or coils. Magnetic core. Core provides path for the magnetic flux. Core मकनातीसी भाव के लिए रास्ता फराहम करता है. Two losses occur in core, that is hysteresis loss and eddy current loss, also known as magnetic loss or iron loss. Hysteresis loss minimization is achieved nowadays by making core of high-grade silicon steel. It is magnetic material with high permeability. Earlier, core was made up of iron. Minimization of eddy current losses can be achieved by making thin laminations insulated from each other by varnish. एडी करंट लॉसेस को कम करने के लिए बारीक लेमिनेशन से कोर बनाया जाता है जो वार्निश के जरिए एक दूसरे से जुदा होते हैं. Now second part are windings or coils. Electric current passes through windings. Windings are made up of copper and are wound on the limbs of magnetic core. Windings are insulated from each other. Windings are subjected to I square R losses or copper losses. What are these losses? I square R, power loss or undesirable transfer of energy in an electrical device is caused by the flow of current, that is I, through a resistance that is denoted by R and that requires double power consumption. Primary coil is the coil to which electrical current is supplied and secondary coil is the coil through which energy is delivered to the outer circuit. Coming to the types of transformers, transformers are based on the arrangement of cores and windings. Core type transformers In core type transformers, winding is positioned on two limbs of the core, and there is only one flux path, and windings are circumventing the core. As you can see in the diagram on the right, that winding core के दो limbs के around होती है और भाव का सिर्फ एक रास्ता होता है. These transformers are quite favorite in high voltage practical applications like distribution, power, and auto transformers. Auto transformers. An autotransformer is an electrical transformer with only one winding. Auto refers to the single coil acting alone, not to any kind of automatic mechanism. In an autotransformer, portions of the same winding act as both the primary winding and secondary winding sides of the transformer. In this thing, just remember कि ऑटो ट्रांसफार्मर में एक ही वाइंडिंग होती है, इसकी वाइड कॉइल अकेले काम करती है और कोई ऑटोमेटिक मैकेनिज्म से काम नहीं करता और इसकी एक ही वाइंडिंग के हिस्से प्राइमरी और सेकेंडरी दोनों वाइंडिंग्स के साइड्स के तौर पे काम करते हैं. Shell type transformer. The shell type transformer has three limbs or legs. The central limb carries the whole of the flux and the side limb carries the half of the flux. Hence, the width of the central limb is about the double to that of the outer limbs. The primary and secondary both windings are placed on the central limbs. शेल टाइप ट्रांसफार्मर के तीन लिम्स होते हैं. बीच में लिम्ब यानी मरकजी हिस्सा होता है जो पूरे फ्लो को ले जाता है, जबकि साइड के लिम्स में फ्लो का निस्फ या आधा हिस्सा फ्लो होता है. लिहाजा सेंट्रल लिम्ब की चौड़ाई बाहर साइड लिम्ब से दुगनी होती है. क्रॉस और एच टाइप ट्रांसफार्मर. Combination of two shell cores set at 90 degree to each other, as you can see in this diagram. Transformers used in electric circuit of X-ray. Auto transformer is used to precise the power supply to single value like at 220 volts, so it should not fluctuate, and it is the part of imaging system that receives the power from the main supply. ऑटो ट्रांसफार्मर्स को 220 वाट की बिजली की फराहमी को दुरुस्त करने के लिए इस्तेमाल किया जाता है, लिहाजा इसमें उतार चढ़ाव नहीं होना चाहिए. ऑटो ट्रांसफार्मर सप्लाई वोल्टेज to X-ray tube through step-up high voltage transformer and to filament through step-down low voltage transformer. It is different from the conventional transformer because it contains only one winding. So that's all for today, and here we end our topic. If you like the video, please like my channel and subscribe my channel. Thank you.